Welcome to YouTube Science Communication. Hi guys, I'm Hoshi Wang. This is the last video I have made for this class. In today's video, let's talk about the history of birds. So let's begin. What is a bird? Its definition refers to a warm-blooded egg-laying vertebrate distinguished by the possession of feathers, wings, and a beak, and typically by being able to fly. However, birds did not originally grow features like those. To figure out how they evolved, we have to look at early ancestor of birds, derived from a clade of theropod dinosaurs called paravians. What did paravians look like? Like other theropods, all paravians were bipedal, walking on their two hind legs. The teeth of primitive paravians were curved and serrated, but not blade-like except in some specialized species, such as Dromaeosaurus apatensis. The serrations on the front edge of Dromaeosaurid and troodontid teeth were very small and fine, while the back edge had serrations which were very large and hooked. Paravians diverged from other Manx-raptorans no later than 160 million years ago. We don't know the exact range because lack of fossil evidence. However, paravians are not rarely considered the earliest birds, but birds indeed evolved from them. For more than a century, the small theropod dinosaur Archaeopteryx from the late Jurassic period was considered to have been the earliest bird. Archaeopteryx is a genus of bird-like dinosaurs that is transitional between non-avian feathered dinosaurs and modern birds. The fossil records show it was roughly the size of a raven, with broad wings that were rounded at ends and a long tail compared to its body length. What makes Archaeopteryx different from earlier paravians is that it could likely fly, but if and how exactly it flew remains a mystery. This paper presents two hypotheses about bird evolution. The arboreal hypothesis states that active avian flight evolved from the trees down through an intermediate gliding stage. Whereas according to the terrestrial hypothesis, the basic elements of the flight stroke motions developed in ground-dwelling reptilian species relate to feeding behavior. The Archaeopteryx lineage evolved alongside dinosaurs, but they didn't diversify into modern birds until after the KPG extinction event.
This time known as the Cretaceous Paleogene or KPG extinction event. Like all mass die-offs, the KPG had many causes, but probably the biggest of them was a giant asteroid that struck the Earth, sending enormous amounts of ash into the atmosphere, blocking out sunlight, and creating a vicious cold snap across the planet. Without the sun's energy, entire plant communities died, and the animals that relied on those plants perished with them.
When the meteor crashed into the planet, it created a lot of dust in the atmosphere, which disrupted food chains. Plants did not get enough sunlight to grow, so dinosaurs that relied on those plants also died. However, 4 distinct lineages of birds survived the KPG extinction event 66 million years ago, giving rise to ostriches and relatives, ducks and relatives, ground-living fowl, and modern birds. Today there are over 10,000 bird species, all descended from Archaeopteryx ancestors. Let's do some review. The first step in the evolution of birds from dinosaurs was the evolution of Archaeopteryx in the paravian lineage. Archaeopteryx diversified into different bird species, also they are all dinosaurs, and after the KPG extinction event, 4 lineages survived and evolved into all species of modern birds. That was a brief introduction of the history of birds. When you see one of them next time, can you remember that they are actually the last survival of dinosaurs? Thanks for watching. This video is part of a class called YouTube Science Communication, where we learn about history of life on Earth and make educational videos about it. If you want to see more videos like this one, you can hit the subscribe button. And if you want to make a video like this alongside us, you can know how on our Patreon page. Link in the description. See you next time.